Kapıyı çeksene hacı. So never everyone, I'm still trying to make the settings. I still don't have all the settings already. Is there anyone connected? I'm still trying to make some settings. Hi. So I hope that everything is right. I will check it from the other laptop if it can work. I hope that it doesn't affect the sound. Why not working? So enough. Let's check how many people are in right now. Current viewers, just one person. And I'm still trying to see it from the other laptop, or let's see it from phone. Let's turn off the sound of YouTube. Let's see it, how it works in here. I hope that the sound is okay. I hope that the sound is working. Ama the video is not coming. The video is not coming. Why not coming? It says alive. It should come. Or I should try once again. So I hope that it's working right now. Let's make a fifth. Probably it's coming after I do the things. Yes, right now it is working. Let's see. There is still one person in here. Perhaps it's me. I don't know what's going to happen. So let's do that in here. Was there a question about this? I don't remember. There wasn't a picture about this in YouTube in the Viber group. Let's write my name in here and see it from there. How it works? Yes, now we have at least two people. There is three. If one of them is me right now, yes, this is working good. So can we start right now? You can write a comment so we can communicate over comments. This program I just learned on this program on Thursday, I think. Right now I did install it to my own laptop. This is the first time I'm using this. That's why it can take some time. So let's go back to the Viber group over there. Yes, you have circled some questions. It's good actually. So I'm checking the types of the examples. and probably this is from even before. But if I remember, there was no problem about this page. Right now, two people are watching. So how can I send you the link? One watching right now. What about the second? The second is gone. What about voice? Can you not do it? Yes, it will be there. Okay. So enough. I can write there a comment which is like don't watch the first how many minutes. Okay. Yes, we have enough number of people. So we can start. So if I remember well, there was no question about this page and also this page in the Viber group, and about these three examples there is the last there are videos in YouTube about these types of questions. I have seen these questions in one picture. I think these weren't the questions that I think it was in Hannah's picture. Let's check. No, it's not in there. In one picture I have seen these examples. So did you meant these examples? I think who sent this picture? Let's check. Ari. I think probably he meant modular arithmetic examples probably in this picture. That's fine. I'll go to the next page and solve some questions in here. Let's take one question like this, which is like the harder ones. So these are the beginning ones. I hope that the sound is okay. So now let's start. Let me check before I start something else. So now let's start solving with this example. Where did I put the pen? Yes, in here. So now in this type of questions, firstly we decrease the numbers. If you have some numbers in the equations, let's call this as an equation. If you have some number bigger than modular mod in here, number 6 in here, so first we decrease those numbers like under 6. 5 is not bigger than 6, but 13 is. So 13 divided by 6, the remainder will be 1 is equivalent to, in mod 6, 621. We should divide it by 6 and look for what's the remainder. 1 times of 6, that remains 0. When you move 2, there is no 6, so you move the next one. In 21 there are 3, it's going to be 18, and 21 minus 18 makes 3 also. So then firstly we want to move this plus 1, get rid of this plus 1. So to get rid of this plus 1, we add this up to the 6. That was the idea. That's why we add plus 5 in here to make 1 into 6, and we have to add plus 5 in the other side as well. So it's going to be 5x plus 6 equals 8 in mod 6. So now we have some numbers bigger than 6. 6 divided by 6, the remainder is 0. 5x plus 0 is 5x. So then 8 divided by 6, the remainder is 2. So then, to get rid of plus minus number in here, we add it up to the 0. If it is a negative number, you can make it 0. Like if you have minus 2, you can add plus 2 to both sides. No problem with that. When you have positive number, you add it up to the mod in here. So then 6 divided by 6 becomes 0. So 5x plus 0 is 5x. So then to get rid of the number 5 in here, we want to find 1x is equivalent to a number. We want to find the result for 1x. That's why we look for multiples of 5. 5, 10, 15, 20, 25, 30. I mean, you think about those numbers in your mind. Which one of those numbers? Efendim kızım. Sen yazamazsın kızım. Ben şimdi abilerle ders yapıyorum.
Ben de. Ben iki kişiyim.
Olmaz. Neyse. Sorry about this problem. That's my daughter speaking.
Bilgisayarım olsun mu küçük?
Kızım ben şimdi ders yapıyorum. Olmaz ama. Bak abiler beni dinliyorlar evlerinde. Olmaz kızım. Now guys, I'll continue. I'll try to stop her. Kızacağım ama. So now, when you divide 10 by 6, the remainder is 4. When you divide 15 by 6, 12 plus 3. When you divide 20 by 6, 18 plus 2, the remainder is 2. We want the remainder to be 1x, 1. So when you divide 25 by 6, 24 plus 1. So the 5 should be 25. We multiply both sides by 5. 5 times 5, 25x is equivalent to 5 times 2, 10 in mod 6. So then when you divide 25 by 6, it makes 1 times x, which is x. 10 divided by 6 is 4. This means instead of x, I can write such numbers, which is when you divide those numbers, the remainder should be when you divide those numbers by 6, the remainder should be 4 always. So that number can be 10 in here. That number can be 12 plus 4, 16. And that number can be like 24 plus 4, 28. That can like 30 plus 4, 34. So we should write all those possible numbers as kind of like in a mathematical way, which is those numbers, they will always be like a multiple of 4 and plus 4 more of it. 6 times 1 plus 4, 6 times 2 plus 4, 6 times 3 plus 4, or the negative multiples can be counted also. So this k should take integer values. Efendim kızım. Bak kızım. Şimdi şey var. Ne yapalım biliyor musun? Ben küçük bilgisayarı sana veremem. Buradan çünkü abiler bana comment yazacaklar. Tamam. Buraya tabure getir. Tabure getir buraya. Küçük bilgisayarda sen bakacaksın. Beni dinleyeceksin, tamam mı? Çık kızım. Bir git Allah aşkına ya. Neyse. So now, I think one question is enough. I think, or I don't know, is it enough or not? Can I just make another question right now about this? Perhaps it will take time. We can do, but it will take time. So then, let's go back to the exam questions PDF. In here, do I remember seeing this? I think I saw one question like this, ama it can be from previous times as well. Is there anyone who wants me to solve this once again? We have, I mean, some of you has asked this in class too many times. I did answer to them in the class. So this was the one which Hannah sent, perhaps I don't remember. Let's solve one more questions. Let's keep it like in the video. I don't remember very well. Tamam kızım, aferin sana. Bravo. So now, let's copy this question to the other side.
Bunu yap, tamam mı? Bunu yap, tamam mı?
Tamam kızım, I will write that one.
Sonra eğitim bunu kesin yapacak.
So now everyone, kızım şuraya tabure getirsen.
Tamam.
Okay, Lerida has written that these are not so hard, so let's not lose time with these things. Tamam olur kızım. Tamam getir onu otur hadi. Gel onu otur sen onu hadi. Okay, let's skip these questions. As you wish it to be. Hadi gel kızım. Şunları da kulağına tak. Beni dinle sen, tamam mı? Sen ama sakın konuşma çünkü abiler rahatsız oluyorlar sen konuşunca. Şimdi abiler beni dinliyorlar bak böyle.
Akşam oldu.
Haha, akşam oldu.
O sonra evine nasıl gidecek?
Bilmem. Gider bir şekilde. Tut bakayım şunu kulağına tak.
Yapıyorum.
Evet, rahatsız ediyor.
Yaptı.
So enough. Let's go forward. Tak sen tak. Her zaman ben takamam. So now I don't remember seeing this question. Aha, I remember seeing these kind of questions. So from here, which one is the hardest? I think these two, like they have x minus 1. So let's take this one, or I can make another for you in here. Let's put this to garbage. So let's make another one for you in here. No, I don't care about the numbers. I'm going to change the numbers like 5 times 2 to the power of x plus 2. So then minus 3 times x to the power of, let's say, not x, 2 to the power of something. 2 to the power of
Takamıyorum.
x
Baba takamıyorum.
plus 3.
Baba takamıyorum. Yazayım mı ben bunu? He?
Kızım benim işim bitsin ondan sonra yazdıracağım sana, söz veriyorum. Ama şimdi benim işim var kızım ya. Beni rahatsız etme ya. So now everyone, sorry about my daughter. 2 to the power of x minus 1. Let's put it in here.
Böyle.
And plus not 4. 4 is a multiple of 2. I'm going to try, let's say 7 times 2 to the power of x. Let's say this, we have the question. So let's remember the idea. When you have such questions, you look for, we have base 2 and the powers of 2, and they are in the algebraic form. So you look for the smallest one. Okay. The smallest power among them, which is x minus 1, is the smallest. That's why we will try to move x minus 1 out in each place. 2 to the power of x minus 1. So then 5 times we will write a power of 2. Which power of 2? From plus 2 to come x minus 1, how many steps do you go back? When you go 1 back, it's x plus 1. When you go 2 back, it's 2. When you go 3 backs, it will be x minus 1, which is x minus 1 plus 3, it's x plus 2. So then minus 3 times 2 to the power of, from x plus 3 to come back to the x minus 1. When you go 1 back, 2. 2 backs, 1. 3 back, 0. 4 back, when you go 4 times back, it will be x to the power of 2 to the power of x minus 1. So there will be 2 to the power of 4 in here. So then in here this is 2 to the power of x minus 1. So what number is in here? We have 1 times of it over there, and plus 7 times from x to go, to remove 2 power x minus 1, 1 step behind we go. So 2 to the power of positive 1, 2. So then in the next step those things will simplify each other. Kızım bir şey basma oralarda. So then inside the parentheses 5 times 2 cube is 8, minus 3 times 2 power 4 is 16, and then 1 plus 7 times 2 is 14. So 5 times 8 is 40, and this is 48 if I remember well, and 15. 40 plus 48 is going to be 88 over 15. We cannot simplify those anymore. So now let's go back. Uh, let's go back to the original PDF. So I don't remember seeing this type of questions. I don't remember seeing this type of questions. I don't remember this type also. I don't remember this type also. Not this one. Not this one. Not this one. I think I saw something like this. Also, Leridas has written that over there. She sent me some new pictures. Let's see the new pictures as well. So these are okay about polynomials. Okay, so we have polynomials, some questions from sets, some from questions from functions, sets, and then radical equations. We have radical equations. Yes, I have seen these ones on the right side. Okay, let's take one question from here and then move on to the next types of examples. So after this page, I need to solve radical equation question. Oh, okay, very well. So now, Derrida, can you solve those ones? Okay, I saw the pictures in the Viber group. I will do that. Don't worry. So I'm going orderly. Kızım bak şimdi ben abilere ders yapıyorum. Bak görüyorsun ya bunu abiler evlerinde oturuyor, izliyorlar bunu evlerinde. Bak sen şimdi içeri git, oyna. Ben sana daha sonra resim yapmana izin vereceğim. Ya işte öyle olur. Tamam ben sana daha sonra izin vereceğim resim yapmana. Keşke sen de abileri görsen. O zaman utanırsın gidersin dışarı.
Onu ben yapabiliyorum.
Sorry about this Turkish part. I cannot stop my daughter.
Pembe yazıyorsun.
Seni yazdıracağım ben bir şey. Okay. So enough. It's home. Oh, I'm sorry about that. I cannot affect the things. So now, firstly, let's organize this 128. It's a power of 2. Fifth root of 2 to the power of 4. Then cube root of 2 to the power of 7, if I remember well. So then, we want to connect these cube roots. That's why we are going to put this 2 to the power of 4 into the cube root. We want to connect to the radicals. We want to make it like just like one radical expression over there. So power 5, degree 5, and then the number between them will be moved in, so there will be no number in here, and then this is cube root, and inside the cube root we already have 2 to the power of 7. Cube root ended. Kızım. Bağırma. Bağırma. Kızıyorum. Now 2 to the power of 4 will come inside the cube root, so we have to make a changing. What kind of changing? Since this is a cube root, when you put it back, you take power 3 of it when you put it back inside the cube root. So then, since there is nothing else between those two radicals, I can connect those two radicals, which is, remember the rule, we multiply their degrees. And then 2 to the power of 4 times 3, 12 is going to be here, times 2 to the power of 7. And then right now we have a 15th degree. 3 times 5, 15, and 12 plus 7 makes 2 to the power of 19. That's enough, I ask in here. Actually, remember that we can even move this 19, some of this 19, since it's bigger than 15 back. Like we can make it like 15 plus 4. So 2 to the power of 15 comes out as 2 to the power of 1. 15 divided by 15 is 1. Then inside the 15th root, 2 to the power of 4 remains. This is good answer. This is best answer. So now, let me go back to the original PDF. So I was checking some things in here. But my daughter changed something in here. So now we have the 5 people. Doesn't matter. Now original PDF, let's go back there. And I have seen over there an example with radical equations. The ones like A, B, C, D, E, F, I think I solved them in the class. So let's do something from here. Let's take one of these questions to there. Which one seems hardest? I think this is. Since there is 2x, it's the one. Because when they are like x with something, it's hard to take power 2 for some of us. So now, I'll solve the 26th one in here. Also, let's choose pan. Then these ones, please. Which ones? I don't know. I mean, when I check it over there on my laptop, and Hannah wrote these ones. I hope that right now we are talking about the same example, this example. So probably it's about this example. So right now I also opened the video over there. It's kind of like 1 minute behind. So when you write a comment, it's like 1 minute before comment. That's why it's kind of weird. So now 26th question. Let's go there. We have square root of something equals 2x minus 1. To be quick, I didn't write the inside part. You should have. You must have. So when we have radical expressions, firstly, the radical expression should be single, alone. Right now we have just square root. After square root, we don't have plus minus a number, or we don't have 5 times square root of something. So it's already alone. So if it is alone, take the power by looking for the degree. Since this is square root, we are going to take square of both sides. Square of square root with the things inside should be written in here, and this is with parentheses. We will write over there, and power 2. 2x minus 1 to the power of 2. So then, when you take square of square root, the square root goes away. So you write the things inside as they are. 4x squared minus 2x and plus 5. And this is very important, guys. There are some people who made the mistake, like for opening power 2. I'm about to finish checking the quizzes. So this idea is very important. So I believe that all of you knows this property. All of you memorized this property. A plus minus b squared, which is a squared plus minus 2ab plus b squared. If you feel that you have a problem with opening power 2, you can use it right now as I'm going to do. So a is the first thing in here a, the second thing in here b. Write the rule somewhere else, keep it written. Wherever you use your power 2, write the rule somewhere else, then name them as a and b. After that, continue to open, which is the first will be a squared. A is 2x right now. Since it is 2x, two things over there, we should take square of both of them. So then after this, between them right now we have minus, it should be a minus. After minus 2, after 2 there should be a. Right now a is 2x. So then after a times b, right now b is number 1, and plus b squared, which is number 1 squared. Let's write the number 1 better. So then we open the power 2. There is nothing more to add in here to put in there. So let's copy everything down once again. 4x squared minus 2x plus 5. Now we should open one more parenthesis, which is taking power 2 of both of them. 2 squared is 4, x power 2 is x squared. So then 2 times 2, 4x, and plus 1. So then, in the class I have done this quickly, but in here let's take the whole process, which is if you move 4x squared other side, it's going to be minus 4x squared, and in this side we already have a positive 4x squared, and then minus 2x plus 5 equals minus 4x plus 1, which is those two 4x squares, they will make 0, like 100 minus 100 plus 100 minus 100, like plus, let's say x squared is equal to y plus 4y minus 4y makes 0. So then we have minus 4x and plus 2x. Remember the idea, move always the smaller one. Minus 2, minus 4. Minus 4 is the smaller one. Move minus 4 in here, it's going to be plus 4x. Copy minus 2x. Plus 5 cannot stay here anymore, you should put it other side as minus 5. And positive 1 should stay in here, you mustn't put it here. So 2x equals minus 4, 1x equals minus 4 over 2, minus 2. So right now, in radical equations, sorry, you should check your answer. You should check it. Is it really working or not? Sometimes the answer we find is algebraically true, but there are the things, especially when you have square root, you cannot use negative number inside. You cannot use negative number inside, false, and you cannot have negative answers. Like square root of 4. When we actually do the calculation, it has to be plus 2. But there is algebraic possibility that it can be minus 2 as well. But with the definition, we define that the result of number examples should be always positive results. So then, when we put the minus 2 in, I see that directly right now in here, since x is a negative number, which is the result part will be 2 times minus 2 and minus 1, which is going to be minus 4 minus 1 minus 5. There cannot be negative answer. So no solution. You should write this explanation, it's important. No solution. Yes, we have found one thing, but it didn't work as we hope it can, it would. Or so we say there is no solution to this equation. This is a false equation. So that let's check the comments once again. Okay, do we have to leave only one square? One square. Yes, the square root should be on the comment. Like, let's go back to the original exam questions PDF. Check that in here, in the example C, before this equation we have minus x. We have done it in the class. The minus x cannot be here, you put it to the right side. Or here we have plus 4. Plus 4 cannot be radical. The radical one should be always alone. There is only one type of example, which is we should choose at least one of them to leave alone. We mustn't work with both of them. You put one of them to other side, so it will be easier then. Also in here we have something additional. We should put those additional things to the other side. So right now, about the comment part, I think I did answer that comment. So I will go back to the Viber questions. So I don't remember seeing this. Probably I have video about this. Probably I have a video about this. And did I see this one in there? Let me check once again. Yes, Eliona has sent a picture. Is this picture from from today? It can be from previous days. Sorry about this. Yes, probably Eliona wanted me to solve the radical equation part, not the. I think these are simple ones. This is what I think, of course. If you need these examples, you write me again. So then this is also with Pascal triangle. It's kind of a unique way. So now these are the most wanted questions, especially by Lerida. So the Lerida has sent me whole page, but later I wanted her to clear some examples. So she especially chose which ones? 15, 17, and 18. Let's do those examples first. So while I do them, you can check these questions again. I'm going to do right now directly. I will go to the directly 15, 17, and 18. Check the other ones. If there are some other ones, write it in the comment part. If there are some other ones that you want me to solve in here right now, please add it in the comment part. So 15. Let's start with the 15. Now, what's that? What should be the number of the minimum and the maximum elements of B? A union B and A. Okay, and this is playing with circles. Good. So, we should put like two sets. Normally we had some kind of examples before in the class, but I skipped some. Sorry about this. I came home late. So, look at that. When you put the numbers in, like A union B, all of them has like 1, 2, 3, 4, 5, 6, 7. So I'm going to place them in here. Let's say this is A, this is B. So inside A, A should be the small one. Anyway, we have the numbers 1, 3, 4, and 6. There is this thing. Let's remove 1, 3, 4, and 6 from the union. I can place the remaining numbers all into A, some into B, some into the intersection part. So, right now, I want to get minimum elements. Let's solve for the minimum. Also, let's do it with colors. Whatever I'm going to write is about the minimum elements. So, I want to get the minimum elements in B. And A is 1, 3, 4, 6. So I place all those remainings right now. Look at that. I have to place this 2, 5, 7 into the B. 2, 5, and 7. Sorry about that. This is not okay. Right now, whatever I'm going to do with red is going to be about minimum elements. So about the set B, there is nothing clear in here. I can change it as I wish. Right now, the red one is the set B. All the things about red, whatever I write about red in red color, this is for minimum, getting minimum elements. Look at that. I can increase the size of B. I can add the number 3 and 6 into the intersection part. So then, what happens then? Look at that. Number of elements in B. If I add those two to the intersection part, number of elements in B is going to increase. So I don't do it. I go back, but it was. So right now, if I write only 3 things in here, the set A, is it as I wanted? Yes, it's 1, 3, 4, 6. Yes. The set B, 2, 5, 6. The union of them, 1, 2, 3, 4, 5, 6, and 7. So minimum number of elements in set B is 3 elements, which is 2, 5, 7. So right now I am going to change the color into the green. Whatever I do in green is going to be like, come on, for maximum elements question. Let's copy this set B and let's make this second set in green color. So remember that when I made this set larger over there, so I can include, why is this happening? I can include 3 and 6 into the B, 3 and 6 into the B, and I can make it larger. I can make it larger in here, 3 and 6. And this doesn't affect anything. Like set A, staying the purple ones, 1, 3, 4, 6. Set A, I mean, I didn't put any other number into set A. and 257 should be out of A because they cannot be in A. But right now set B, the green one, number of elements, 3 in here, 2 in there, 5 increased. So to get the maximum elements, I do add every element of A into B as well. Right now this green set, which is the set B, for maximum elements. Can we write such a set? Like set B has all the numbers from 1 to 7, which is 7 elements. So right now, what are, the given things, are they matching with the result that I am doing in here? So do we have a set A 1 3 4 6? Yes, we do have the black one including 1 3 4 6. So about the set B, there is nothing clear in here. What about the union? When I connect A and B, do I have the whole set 1 2 3 4 5 6 7? Yes, I do have. So everything is good. We can make it at most 7 elements over there. Sorry about that. I think I do it like slowly. These are easy. You can move on harder. What are easy? I mean, didn't you send this picture? 15, 17, 18. I think you sent this picture to me. Yes, Lelida, you circled them. Come on. So now 17 in order. So you can still check the main PDF from your, I don't know, whatever you have over there. If you print it with papers. Lerida has circled these ones. In the picture, they are all circled. I mean, she sent me the picture. Yes, in the Viber group. Okay, now this is the 17th one. Yes. So now let's put circles to make sets. We need set A, set B. What else do we need? The universal set. The universal set, let's put like this. Okay then. Set A, 2, 3, 4, 5, 6. Set B. Out of B we have. Okay. Out of B, what numbers do we have? Let's start to place them. So those numbers should be, let's say this is B, this is A, and the big one is universal, as you can guess. Why is this happening? So now, -1 is out of B. Is it inside A? No, so -1 is somewhere here. 4, B prime means 4 out of B. Is it inside A? No, it is not, so it should be somewhere there. 5, it is out of B. Is it also inside A? Yes, I can put it in there. Out of B, inside A. 7, out of B, inside A. We can place it inside A and out of B. So then 8, is it inside A? Yes, it is. So we place it in here. So this has to be set A. These are all the elements which are out of B. So out of B, I cannot write any more elements. I cannot place 6 in here because they are all has to be written over there. That's why the other elements in here in A, I need to increase the intersection. I think I will write many numbers in there. So like number 2 should be in intersection part because number 2 is not out of B, it is inside B. Then 3 should be intersection. Then 5 is in here, 7 is in there, 8 is in there, and 9 should be in intersection part. So we used this knowledge and this knowledge. Let's go for further. The universal set x, what kind of x things? The numbers like from -1 until 10, the integer numbers, that's the universal. In big set we must have all of these numbers. Do we have -1 somewhere? Yes. Do we have 0 somewhere? No. So I cannot put anything anymore out of B, so I should put 0 into B. So then do we have number 1? No, we should put it into B. So then do we have number 2, number 3, number 4, number 5, number 6 we don't have in here, 7, 8, and 9. Can I include 10? No, we cannot write 10. It's not equal to 10. So then that's all. What else do we need? A difference B. A difference B is 5, 7, 8. Let's write it with the set idea. list form. So then B complement difference A. Out of B we have 5, 7, 8 minus 1, 4. So B complement difference from A is the ones like out over there. Minus 1 and 4. So the last one. Ooh. A complement union B. Everything out of A, 0, 1, 4 and this part, and add B in. So if I paint over there, normally I can imagine it right now, but for you to see the idea, I'm going to paint it over. So out of A, we have these elements, this part, those elements, and then I need to connect these things with B. So inside B, I have 0, 1, 6, and these ones. So all of those numbers, all of those places, this is the first one. This pink one or pinky one, from this pinky one, I need to remove some things, some parts. What kind of parts should I remove from the pinky part? Again, it is starting with A complement. Out of A, we have these two parts out of A. Intersection with B. Out of A, we have these two parts, and from these two parts, which part is also inside B? This one. So then, the pinky one, difference, the blue one. So set C. From pinky one, we should remove the blue part, which is minus 1, 2, 3, 4, and 9, I think. Minus 1, 4, 2. That must be 5 things, yes. 2, 3, 4, 9. Sorry about my handwriting. This is something which is hard to write. The tool I use. So right now, by the way, some radical equations I meant. Some of the okay, Lerida, the previous comment that she made, and I have asked something about this. Okay. Okay, no, good. Because of the time difference, that the time I took and the one I mean the timing it you say you hear it, that difference. So then what was the next one? Probably it was the 18th one. Lots of x's. I like x's. I'm a math teacher, that's why I think. So now let's take the 18th one. So till I finish this one, if you have another question about this type of questions, if you have any other question that you want me to solve from this part, please write it in comment box or in Viber group. After this example, after solving this example, I will check that. So now let's go there. This seems easy to me. I didn't read even. Let's check. I quickly read that. I think every part in here are given like kind of numbers. We just need to play with x's, I think. Let's check that. We have only two sets. I see A and B. We can place them like this: A, B. So this is A difference B. A difference B inside A different from B. 6x minus 14. This is B difference A. 4x minus 6. These many elements are in here. A union B is 28. Okay. If I say this is A, when you add them all, this is A, another letter. When you add them all, it should be 28. B difference A difference B, A. Okay. A difference B is equal to B difference A. So A difference B, B difference A are given and they should be equal to each other. Let's check that out. 6 minus 6x plus 4 should be equal to 4x minus 6. Always move the smaller one. 4x coming in here. So then let's arrange the rest. 6x should remain in here, plus 4 other side as minus 4 and minus 6. So 2x is equal to minus 10. So 1x is equal to minus 5. It was 14. And 6x minus 14 it was. My bad, sorry. Luckily I realized before you write it in comments. Perhaps you wrote it in Viber group. I don't say that. So let's correct it. I see the difference because minus 10 over 2, it would be minus 5, like impossible. You cannot have minus 5 elements. So now it was 6x minus 14 in here, and this minus 6 is to go here. It's minus 14. So after we decide that 4x is going to be here as minus 4x, of course, 6x remains in here, minus 14, other side as plus 14. 14 minus 6 makes 8. So 2x is 8, 1x is 4. So that means 6 times 4, 24, minus 14, 10 things in here. 4 times 4, 16, minus 6, 10 more things in here. Remember that if you say a in here, 10 plus a plus 10 should be 28. I hope that you can see as quick as I do. I mean 10 plus 10, 20. It will come here minus 20. A is 8. So now I'm going to check the Viber group and the comment part. Can we use colors to solve examples if we are such? Yes, you can take colors between you, I mean with you. No problem. You can write in any color. But I like you to write something that you can clean, because some of you like can't solve it, doesn't want to solve it because they don't have colors. That's why. Sorry, some of you doesn't want to solve it because they can't clean it back. If you write something with something that you can clean back, it's better. Anyway, there is no more question from this part in comment box. Comment over there, and let's check the Viber group. Did you write any other? Lerida has sent her comments, teacher. These ones, if you can. Yes, I'll do those things with FOG. Don't worry. I'm going like step by step. Can you write like your proof? Teacher, as this type of examples can we write? What is this type? So I'm reading the. I think I did explain this example that Lerida has asked in the. Why didn't I see that? Okay. Okay. I mean, I didn't understand your question. Tomorrow, first hour, I will be with you and you will explain me better. So we can solve some more questions tomorrow, first lesson also. So then, let's do this till 9 o'clock and then you study more. I hope in till 9 o'clock I can finish these pictures that you sent me. Alma, I think there was a video about this. Yes, if I remember well. So, if there is not video after the, I will after when I close this. So now, let's go to the where I am so confused right now, where to check. So there is no more questions about this type, this place in the Viber group and in the comment place. So I'm moving forward. I haven't seen such questions in the Viber group pictures. I didn't see a picture like this. I don't remember seeing a picture like this. I don't remember seeing a picture like this. I think I saw something like this. Drew, did I see? In under fog. Probably this wasn't a question. These weren't a question. Okay. So these are not the questions. These are the. Who sent these? Hannah has sent these. Probably these are Hannah's question. Okay, drawing graph. Let me take the hardest one in here. I think the last one in here, over there. So let's take this one. So remember that there are two ways to draw graphs. The first way, find x-intercept and y-intercept. If you try to find xy intercept in here, you will have a rational result in here, which is when it's equal to 0 or something else, you will have over 3 and it will be hard to show. Let's put the squares in. Let's make the level a little bit up. So you will draw x-axis and then y-axis. You will draw them. Let's say you need to draw 2 and 1 over 3. 2 and 1 over 3, where is that? So after 2 you should continue 1 over 3 more, which is like 3 parts. You must imagine it over there and you should choose the first one. This is 2 and 1 over 3. It is harder to find. That's why we don't like to use, come on, I mustn't clean the question. We don't want to use xy intercepts. So I gave you another idea, which is I told you to choose any two numbers you like, because at the end we are going to draw a line, and to draw a line we need to know at least 2 points where it's going to go. When you find 1 point in here, you will draw a line. So when you find the next, if you do it in here, it will be like that. If you find the next in here, it will be like that. So it's all about finding 2 points. Any 2 points, doesn't matter, any number you like. So I mostly like to try f of 0 and f of 1. Let's start with f of 0, because 3 times 0 is 0, 0 over 5 is 0, and 2 minus 0 is 2. If you write the calculation, it's better. So since I want you to write the calculation, I'm going to write the calculations in here. And 2 minus 0, 2. F of 0 is 2. Let's show it over there. When x is 0, the result is 2. That's the point in here. So now, if you try f of 1, 3 times 1, 3 over 5, it's going to be a rational number. I'm doing this method because I don't want to deal with rationals. That's why instead of x, I need to choose a number which is divisible by 5. That's why I choose the number 5. 2 minus 3 times 5 over 5, which is equal to 2 minus 5, should be here. 5 over 5, 1, and it's 3, and minus 1. F of 5 equals minus 1. 1, 2, 3, 4, 5. When x is 5, y is minus 1. So we have it in here. We just need to try to draw it like a straight line. So like this. Try to do your best. I couldn't do it better. I could do it better if it was with a notebook. Right now it's hard to write from here. I hope that this was the question. Yes, they are. She wrote it in the comment part, so I was right about that. So now, this was the hardest among them. So I hope this is enough. In here, for example, for this one, you should choose 0 and 2. Not you should. You can also choose 4 and 6. Any two number divisible by 2. You can choose in here 3 and 6, 6 and 9, doesn't matter. But I mostly like to start with 0, because 0 over 2 0, or 5 times 0 is 0. It's going to end up always as 0. That's why firstly I choose 0, and then choose the next number. If it is with rational expression, choose the number by looking at the denominator. If it is not, choose 1. 0 and 1 mostly are the easiest. But like there are some, for example, if you put which one do we have such example in here? Sometimes you have minus results. Some people doesn't want minus results. They can choose bigger numbers. Anyway, let's move forward. Yes, and this is the part which most of you wanted to hear once again. Teacher, can you MA subsets have 5 elements. Who is this, teacher? Can you show us an example with subsets, for example? Do we have subsets example in the PDF? I don't remember. The subsets. Okay, tamam, I understand that. Okay. I'm going to answer that. Let's answer to Waldron's questions just before this, because it's about the previous pages. So where can I get it? I wouldn't solve it on here. So it was where? It was in here. After that, I'll go with F4G. So this is the example that Valderin wants. So let's increase the numbers even bigger. G age. So this is about Pascal triangle, which is right now how many elements do we have? 1, 2, 3, 4, 5, 6, 7, 8 elements. So in the Pascal triangle, you should find the eighth row. 1, 1, 1. You should find not eighth row. You should find the row which is going with 8. So this row is going with 2, then 3, then 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. This is the fifth. This is going with 5. Then 6, 15, 20, 15, 6, 1. How do I find these numbers? 5 plus 1, 10 plus 5, 10 plus 10. So the next row, 1 plus 6, 6 plus 15, 15 plus 20, 20 plus 15, 15 plus 6, 6 plus 1, and at the end 1 again. So I want to put another color here. I forgot to change it. I should have changed just before you come, Mama. On the right it's hard to write. On the blue, sorry, it's hard to write. Let's make it open green, and it will be easier for me to write and visible for you too. So this is going with 7, so I need to find how many was there. 1, 2, 3, 4, 5, 6, 7, 8. So I need to find the 8th. Okay, 8. This is going to be 21, 28. This is 6, 56. Oh, so very big numbers. Sorry, guys. 70, 35 plus 21, 56 again, 28 again, 8 and 1. So when you have 8 elements, you have 2 to the power of 8, which is 128. 256 different subsets you can write, if I remember well. 6 is 64, 7 is 128, and this is 200. Okay, you can write 256 different subsets. So these are showing us number of subsets, not number of elements. So number of elements like going like this. With no element you can write one subset. With one element you can write 8. With two elements you can write 28. With three elements like ABC, ABD, ABE, ABF, with three elements you can write 56 like that. With four elements, with five elements, with six elements, with seven elements, with 8 elements. So then with four elements, how many subsets can I write? 70 subsets. Directly the answer. This is the easiest step. The second one, with less than 4. Less than 4 means like 0, less than 4. 1, 2, 3. 3 is okay. I'm on 4, not okay. Less than 4 means it cannot be 4. It should be smaller than 4. So 0 element. So with 0 element I can write one subset. With 1 element I can write 8. With 2 elements I can write 28. With 2 elements 20. With 3 elements 56. So you just need to add them like normally, like 5th grade thing, and write the result. This result gives us how many subsets from here I can write, including less than 4 elements, like no element, 1 element, 2 elements, and 3 elements. So then with more than 2 elements, more than 2 means it cannot be 2. It should be like 3 elements. It should be more than 2. So with 3 elements, check it from here. We can write 56 like that, and plus with 4 elements, this is what for 3 elements. With 4 elements 70. With 5 elements, I check it from here. I'm telling you, then 56, and then with 6 elements 28, with 7 elements 8, with 8 elements 1. You just need to add those numbers, and that result will give us the result, will give us the answer. So there are two more things, like at most. So these 4 words are important in here. You need to know what they are. At most 3 elements means that you can count the 0 element, you can count the 1 element, you can count 2 elements, you can also count the 3 elements. It can be 3 as well, at most 3. At least 4 means you can count the subsets with 4 elements, with 5 elements, with 6 elements. You can count it until check from here. 1, 2, 3, 4, 5. I have in this set 5 elements, so there is no six element subsets in here, just 4 and 5. If it was the for the previous example, for this example, I can go till 8 elements. When I check for 9 elements, there is no subset. When I check for 10 elements, there is no subset. I can write from here with 9 elements. It's impossible. So we continue till 8. So I think this is okay. So right now I'm going to continue with the whose question was this? I think Mirella has asked this FOG. Thanks. Fog. Let's go there. I think after these ones there was also like one Nerida has sent from polynomials. Actually, they are the same ideas with the mm, with the. So this is the hardest one. Let's check. Let's take this one. And the two things in here. Let's say I'm preparing an exam question, and then let's say I'm changing things in here. I'm going to do it even really hard. Then it will take time. Sorry about guys. I'm using your time for the night. Since I put 4 in there, let's make at least this part easier. Just X. And let's make this part harder. Um, 3 2x. Let's make it 2x minus 4. It will be a really hard question. I love that. Anyway, let's start with the easy one. I think GOF will be the easy one. So now, this chapter was a composition of functions, and we are connecting two functions and making them like a one single function. The idea is simple. You go with the order. Inside the first one, you write the following function, which is f of x. So the rest is kind of like opening parentheses from inside out. I need to open this parenthesis. I can open this parenthesis by looking the function f. Function f, what does it say? Function f says that if you have just one thing inside, yes, I do have just one thing inside, you can directly open it as 4x squared plus x. So I'm gonna do that. I won't touch anything else. I'm going to open just f of x, this parenthesis with the rule of f, which is 4x squared plus x. So right now I need to open these parentheses. So to open these parentheses, I'm going to use the rule of G. Rule of G says that if you have one thing inside, it's equal to 2 times of that thing minus 4. But right now we don't have just one thing inside, we have some more things. So I'm going to keep them with parentheses and use the rule of G. G rule says whatever you have inside, when you replace something with this, you replace it in here as well. So we are replacing, instead of just one thing, lots of things in there. So 2 times all of those things, whatever you have in there, 2 times the same thing in both places. It's in here, it's in here, and x, and then minus 4, which is, if you do open the parentheses with normal way that you know, 2 times 4, 8x squared, 2 times x plus 2x and minus 4. Copy it down. So now let's come to the tricky part, the hard part that I say. Inside the first one, I'm writing the second. This is the way that we connect them. This is the way that this sign works in functions. So we will start to open the parentheses, and firstly we will open the parentheses, the smallest ones, from inside out. So I'm going to open this parenthesis. Yes, to open this parenthesis, what rule do we have? Open it with the rule of Gx. So the rule of Gx says that if you have one thing inside, yes, I do have one thing inside, so open it directly. Gx is equal to Gx is equal to, it is same with 2x minus 4. So I can clean gx and write 2x minus 4 for it. So right now I am going to open the next parentheses, but to open these ones I need to use the rule of f right now. Rule of f, what does it say? Whatever you have inside 4 times that thing squared plus that thing same again. 4 times that thing squared plus that thing again. So what is this thing over there? Which is 2x minus 4. So this is like this thing goes in here and goes in there. X, X, X. We are replacing all of them with this. So this is the thing like a minus b squared. Let's write the rule somewhere else like I have told. A minus b squared equals a squared minus 2ab plus b squared. So in this case, what's a here? What's b? This one. So 4 times staying in the beginning. A squared, which is 2x squared. 2x, keep it with parentheses, squared. Then minus 2 times, which is you are going to take square of all of these, not just x. So 2 squared, 4x squared will be x squared. Let's be quick. I don't want to write all of those things once again. I'm going to write what I told right now. So you are going to take all of these, a squared, square of everything in here, 2 squared, which is 4 times x squared. So then minus 2 times a is 2x, b is 4 times 4. Some of you have written plus minus in here, be careful about that. And then plus b squared, b is number 4 in here, 4 squared. Let's close the parentheses and let's open this parenthesis. Since it's plus, we don't have to touch anything. Plus 2x minus 4. Now let's open this parentheses. 4 times 4, it will be 16x squared. Then 4 times this part, it is going to be minus in future. Some of you forget this minus, and I have seen in one paper it was like all times 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 times. You forget the minus. So 4 times minus 2 will be minus at the end. So let's multiply all those numbers. 2 times 2, 4 times 4 is 16. So I need to multiply this 16 by another 4, which is 64x, and plus 4 squared is 16, and this 4 is going to be multiplied with 16, which is also 64. Then plus 2x minus 4 equals, no more x squared, staying same, and then minus 64 plus 2 is minus 62. Minus 62 plus 64 minus 60 makes plus 60, and that will be all. I hope that you understood. Please write it in the comment part so I can see that the exam has been. Yes, I have given the questions. I cannot change. So I didn't want it to affect me, so after I give the questions, I have never checked them again. I really forgot what I wrote in exam paper. I really forgot them all. Yes, they are in my computer laptop over there, but I didn't open them after I give them. I wanted to forget them all because I don't want it to affect me. I don't want to make kind of. I can take like I can use more time for a question which is not in the exam, and you will say that no teacher, you studied this example, we studied this example very much. So right now I have no idea, remember that. So there are questions that I like, probably I asked in exam, I don't remember, I really don't remember what were they. So now, was there? Yes, there was a question. I need to arrange something. One last question from polynomials that Lerida has asked. Later we'll leave it for tomorrow morning. Since I made a lesson right now with you, perhaps tomorrow morning I will be free in the class. So now, Let's go to the exam questions PDF, and this was the question right now we solved. Let's arrange this part in my home. I'm arranging something. Okay. So enough. The next question that Lerida has asked, which are like the from polynomials. I think they were this. Let me check from the. Some of you has given up from watching. Okay, no problem. If there are people still caring. Okay. So this is let us have sent the same question FOG. I hope this is enough. And before that, this wasn't that. Didn't we do this in the class? I think later we have solved those in the class. Okay, Amal, let's do it once again. This is the reason of this YouTube live lesson. So find the following polynomials. I think the one is under, like, I'm looking at to the page 36 right now. This page, okay. These questions are like kind of mixed ones. So let's take one of them. Which one? I don't. Let's take this one. So we can only play with the given ones. This is the given one, and we want to find something else. So in the given one, let's clean that underline. Inside the parentheses, I have x plus 1, and I want to change it with another expression. I want to get inside there 2x minus 3. So now there is this problem right now. I cannot equalize it with 2x minus 3 because it's x. I will mix them. Which one is the one that I look for? So instead of 2x minus 3, I use another letter, 2a minus 3. That means right now I'm looking for the result of p of 2a minus 3. So those two things should be exactly equal to each other. Now I am going to play with the given one, which is 2a minus 3, or let's do it x plus 1, which the one from up equals the one from down, 2a minus 3. So right now I am looking for to get 2a minus 3 inside. Instead of x, what should I replace? Because this is given as x, I want to change it with a. I need to find something like x is equal to a, 5a minus 7, something like that. So plus 1 goes other side, and x is equal to 2a minus 3, and plus 1 will be minus 1. It's going to be minus 4. I directly found what x is in terms of a. So now I'm going to place it in the given polynomial. Normally, we should replace 2a minus 4 for each x in the given polynomial. But when I replace it inside the parentheses, I am already sure about that it will be 2a minus 3 because I did solve it as this equation as equal to 2a minus 3. So I don't even bother about inside parentheses. I just do the changing for outside part, which is 5 times, instead of x, you should replace 2a minus 4, and then 5 times x plus 2 is the original one. 5 times x is changed and plus 2. So now open parentheses, 5 times 2, 10a. 5 times minus 4, minus 20, plus 2 is minus 18. So right now we have the polynomial p of 2a minus 3. The real example wants it as x. So put the x back. 10x minus 18. So now, one more last question that Lerida has asked me. I think the last few examples that we solved in the class. Let's do them once again. Let's remember what they are, which is like being factor, being divisible. They were the questions. These and these. Did I skip any one of them? I think I did skip this one, the second. The remainder is 5. Okay, let's do this. Find the remainder. Okay, so enough. This looks very hard. Let's see. Let me show you how easy it is. If you did listen me well in the class, it's all about making the equation. So now let me try to explain it. So here we have two sentences. With the first sentence, I will find the rule of this polynomial with x minus 3 with the first sentence. And with the second sentence, I will find the answer for the question. So we have one step for the answer, which is finding m. To find m, there's something else is given. So we didn't solve a question like this in the class. Don't worry. Let me show you. So the big polynomial is this one. Write it as it is. So normally we used to write here px, but right now it's px minus 3. That's why I wrote it as it is over there. So for the big polynomial, we don't write the whole rule of it. We write the other one with rule. So when you divide this by x minus 1, there will be a result, mx, and then the remainder is 5. So right now we are going to use this knowledge to find the m in here. So to be able to use this knowledge, what's the way to use this knowledge? We always did the same thing. This place should be equal to 0. To make this place into 0, we should put for x plus 1. There is no need to even calculate it. So instead of x, put plus 1 everywhere. Plus 1 minus 3 equals 1 minus 1, going to be 0, m1 plus 5. This is times. So 0 times m1. Whatever m1, whatever result it has, doesn't matter for us because it's times 0. So this side is 5. So p of 1 minus 3 is minus 2. So x minus 3 is rule given in here. In this rule, we are putting 1 inside there. We are putting 1 in this rule. So put 1 in here. 4 times 1 cube plus m times 1 squared minus 2. So right now this is 4 plus m minus 2 equal 5. So m equals 4 minus 2 is 2. If you put it other side, it's going to be minus 2, and m will be equal to 3. So right now we know what m is. Let's go for the real example part. So let me move them a little bit to the left side in here. Let's do the real example. We will use again the same idea. Find the remainder when px plus 2. I'm going to divide px plus 2 by x plus 1. And there will be a result. Let's now use another letter nx, and I want to find this remainder over there. So then, to find this remainder, the basic idea is making this 0. So there is no need to make the equation. X should be minus 1 to do that. So p of minus 1 plus 2 is going to be, let's do it in here. Let's show it to everyone with the very best written form. N of minus 1 and plus r. I changed every x with minus 1 because I wanted to get 0 in here. That's the way that I use this equation. Make this part 0 and get rid of these things in here. 0 times n minus 1, the thing that I can never find right now, is already gone without finding it, is 0. So I only have the remainder in the other side. What polynomial do I have in here? 2 minus 1 is 1. Look at that. In previous example, I have changed the number in here directly with the x over there. Why didn't I do it in here? Because in the previous polynomial, it was already in the form like x minus 3. So x minus 3, x minus 3, 1 minus 3. So x and same are corresponding in here. But right now, we don't have such a case. So, to find p of minus 1, which is the given formula is x minus 3. From in this formula, this is for the given. To get minus 1, we should do the replacement. This x and the previous x, they mean some different things. This x is about making it is equal to 0. This x about the going to the previous given polynomial. X must be equal to x minus 3 inside part should be equal to 1, which is x must be 4. Now I'm going to open this first rule by replacing 4. 4 minus 3, p of 1 equals 4 times 4 cubed. 4 times 4 cubed and plus m times x squared. M we have found 3 times 4 squared and minus 2, m times x squared minus 2. So 4 cubed is 64. 64 times 4, which is 64 times 2, 128 times 2, 256. 4 squared is 16 times 3, 48 minus 2, 48 minus 2 is 46 is the remainder. So then remainder is equal to 6 plus 6, 12, 5 plus 4, 9, 9 plus 1 is 0, and 2 plus 302. I hope that I don't have a calculation mistakes. So now, let's check the comments over there. I think we should end this video because it's time. We have the first lesson tomorrow. Why do you love hard questions? I already had a question. Why do I have hard questions? Actually, the questions that I say hard to you, they are really easy ones. You think that they are hard. No, I want to change that feeling inside you. That's why I love those questions. And there are really hard questions that even I don't want to see. So I never mention those in the class. Make the exam easy? Haha, impossible. I'm sorry about this. The exam has been submitted. Yes, yes, yes. Never give up. So can you solve the example page 4? M is natural number. Erzen, I think I have a video about this, and after closing this video, after turning off this video, I'm going to share the link in the Viber group. If I don't have a video, I will prepare a video and write back to you. Right now I did talk about this. I see the comment right now. If you check the quizzes, put the results. Okay, I checked the quizzes actually. I won't put the results because I don't want it to affect tomorrow's exam. I I mean, some of you may have something lower and it may affect you. That's why it is better to not know each. After the exam tomorrow, I will put the quiz results, and as soon as I check the exam, I will put those. Anyway, have a good night. About the last Erzan's comment, I'm going to answer after this video in the Viber group. Good night, everyone. See you tomorrow.